So hello everyone, my name is Mateusz Kubuszok. It's nice to be here and be able to talk to you all of you. So today we will talk about, can we have the standard library for macros? And obviously, before we got to the point, we will also talk what are the macros, why we would have, what we would even consider there is something like standard library for macros, why would we need it, or why would we prefer macros to all the other metaprogramming functionalities that we are capable of using in Scala. But let's start with introducing myself. So I am Mateusz Kubuszok. I've been a Scala developer for over 10 years. I've been co-author of Chimney for something about 8 years. It's a macro-heavy library which gave me a little bit of experience that I can share with you today during this talk. Also, I've been blogging at my site kubuszok.com, and I also wrote this book about the JVM in Scala. I'm by no means an expert about the JVM, it's just some bare minimum that I believe it's useful to everyone who codes in Scala to understand what is happening under the hood, what is the bytecode, and etc., etc. So, not an expert, but I believe it's still useful to know those stuff for everyone. So let's get back to the main topic first. What is a macro? So, first of all, it's a code generator. We have Scala compiler, it generates the code. So basically, Scala compiler receives some information about the code that it needs to generate and then runs our code, which generates the code, and it returns the AST that could be inlined and put into the code that we would be using. But this is a special code generator because it's pretending to be a method, as opposed to all the other stuff like Scala PB, which is generating code from some IDL or things like that. And for the purpose of this talk, I am assuming that mirrors, inline defs, inline match, someone inline, someone from, those are all metaprogramming capabilities, but I don't consider them macros. For macros, I only consider things which looks kind of like this, which is a little bit intimidating, but this is the topic of our presentation today. So what would we need macros? What would we go into this very intimidating style of programming? So let's assume that we don't need it. What alternative we have? There is Shapeless in Scala 2. There are inline, mirrors, and Scala compile ops on Scala 3. Both Scala 2 and 3 have something like Magnolia if we are concerned only about deriving type classes. And if we're talking about JVM in general, we also have runtime reflections, which is used by the Java guys to the fullest. So they don't completely need any sort of this metaprogramming stuff. They just do things in runtime and they're happy about it. But the first three is something which we prefer in Scala ecosystems because we want to be type safe. We want to get our errors during compilation, not once we deploy our program to the production. But these alternatives have some issues. I've already made an hour-long presentation, and there I covered that. First of all, it might be really, really slow to compile. Like Shapeless, mirrors, even Magnolia, they can have like really, really huge compile times in some corner cases which you can easily reproduce or maliciously write yourself, or just, happen on production because real-world cases. Then this code not only is slow to compile, but it can also be slow to run. Sometimes you can have as much as an order of magnitude, or sometimes 2 orders of magnitude difference in some really bad cases. Then you find out that debugging those libraries might be really heavy stuff for newcomers. Usually, all those libraries are using type classes. If you cannot derive the type classes, quite often all the feedback you get is something like implicit not found. Sometimes you can use stuff like semi-automatic derivation to get some information like which field is missing or which subtype isn't handled. But if you're trying to use anything like automatic derivation or if your code base is like really, really huge, yeah, quite often you will have very unhelpful errors. And it doesn't have to be a case with macros because I already wrote a library which allows you to basically have not only like helpful errors, this is the stuff you are missing. It might be even information for some nested code so that you can have recursive derivation, and somewhere in the case class, in the case class, you are missing just one information, and you can report it to the user with some helpful hint. Fix this, and it's gonna work. And also you can optionally add stuff like structural logging. So we can say, okay, the code that you got, we got to this point going this way, this way, this way, we tried this and that, this failed, that succeeded. And this way, user will be able to debug their macros. Even if they are not editing the code, putting the print lines, this could do something like, okay, I'll use simple import, and then everything in the scope is starting to print me information how we got there. So we can make it more useful and easier for users. But we aren't necessarily doing this yet. So in other words, when we have shapeless, mirrors, etc., one of the reasons they are quite successful is because it's so easy to start them. You just write regular Scala code and you can deliver, something useful in a matter of minutes. So it's good for rapid development, getting some feedback, understand if it even makes sense to build the stuff that you're building. Also, everything feels lean because it's just some simple Scala functions. For some people, it also feels really principled if you're using shapeless or mirrors because you're handling all of the cases. So it sounds like something mathematical and correct by design. But your users might be paying with longer compilation times, performance penalty, and if something doesn't work, you can spend a lot of time trying to figure out why. With macros, on the other hand, it's much harder to start, not gonna lie. There are no batteries included, so you have to figure out everything yourself. So you might feel that it isn't worth it for quite a while before you get to the point that you feel some return. Development feels clunky because you're basically working on the raw ASTs, so it's doable. Some people liked it, most people hate it. And because of that, everything feels like a hack. So you feel that it's so unprincipled, that it's incorrect by design, you should never touch it, you should kill it with fire. That's the general sentiment of everyone who touched macros and had to deliver something on it, with it. Meanwhile, your users, they may get better compilation times if you know what you're doing, and they may get better performance. And they may get better error messages if you know what you're doing and if you're caring about this stuff, because otherwise they can get undebuggable mess that is impossible to debug, that they constantly complain, okay, I have no idea what it does, and I have no idea what I could do to figure out what it does without putting 100,000 compiler flags and getting this weird error message from the compiler. So it might be a really, really bad experience if you don't care about all of that stuff. And why is that? So when we look at the macros API, we can see a lot of opportunities for improvements. And we'll see some examples. What do I mean by that? First thing, quoting and splicing. So let's compare Scala 2 and Scala 3. On Scala 3, we can see that it looks almost like a normal code. Like we can write some normal code in Scala, put it inside quotes, and this code is, turned into AST. And we have some code which is already AST. We can put it inside this expression, and everything is magically glued together. So it looks great. On Scala 2, it's a little bit worse because we are working with quasi-quotes, which are, quasi. They're not real quotes. Everything is built with string interpolation that is turned by the compiler into AST. So no hints from the IntelliJ, no hints from Visual pseudocode. You're basically writing strings and then running the compiler to hope that it's the right string to write. Then let's try something, harder, like matching types. Like I want to make sure if I receive some type A, and I want to know if it's some kind of option and what is the value inside this option because I want to handle it. So with Scala 3, also we have some nice utilities. We can use this nice little pattern matching option. So it's nice. When it matches, it automatically extracts the inner value, give it to us. And it also handles all of those cases like, what if the type of A is none? Like we can just extract the first type parameter because none has no type parameters, but it will figure out that this is option with nothing applied. So everything works. We are good. On Scala 2, as you can see, if you want to handle all of the cases correctly, you have to write a bit more code. And if it's look intimidating, it's because it is. You have to write a lot of unit tests and a lot of examples to make sure that the code that you've written is handling all of the cases, and then you're going to learn that it's not handling all of the cases one day. But what if we want to create a new type? So like call a constructor, but not like in a hard-coded way we are calling new on like option or on either. We receive some type from the outside and want to call a constructor on it. So we can just hard-code the expression. We cannot use this nice little expression quotes API on Scala 3. Well, on Scala 3, things are getting a little bit worse because if something is not a complete expression, we can unquote it. We can only quote and unquote whole expression, something that is a valid value on its own. Well, also on Scala 2, because the quasi-quotes are, kind of hacky. Things are just working because you're just writing strings. The strings will be type checked by the compiler. So it's kind of sucks, but it's internally consistent with everything else. So, okay, so maybe something else. Maybe let's try build a pattern match. We get some expression. We get a set of, let's say, subtypes that we would like to match this expression against, and see how we could, build a pattern matching, expression. And then you'll see that it's not nice. It's really not nice. On Scala 2, at least you have quasi-quotes. You can build cases separately using this nice little string, and then you can use another nice little string to glue them together, which is, as I said before, not very nice, but at least consistent with all the other stuff on Scala 2. On Scala 3, you have to manually creating symbols. You have to manually build all this AST for cases, and then combine them together into the whole AST for the matching. So a lot of opportunities for making mistakes, or at least spending a lot of time to do something very, very simple. A typical example of let's write expression, print the tree, and let's try to reproduce this tree manually. Otherwise, no progress. Okay, but if we're talking about pattern matching, what could we pattern match? Well, let's say sealed rate and all of its children. But the thing is, sealed rate could have type parameters, and so those children would also have to have the type parameters that would have to be applied, and we would probably have to reapply whatever it's in the type parameter of the parent to the children to make sure that everything nicely matches, etc. So how could we just get the type of the parent and get the right types of all the children? Well, on both Scala 2 and Scala 3, we'll have a lot of fun because we will usually get the symbols for the children, which are, row trees with no type applied, and then we have to manually reapply the types. With Scala 2, there are some features. As you can see, we have a lot of code. I really have to struggle to fit it into a single slide, so you should know how much code you have to write to get something so simple and to make it bulletproof. On Scala 3, yeah, it's even worse because we do not have utilities like final result type, substitute types, things like that. We basically building a map of the types of the parent, maps of the things the children, yes?
There is a substitute API. Does it not work for this use case?
The substitute API?
Yeah, I think there's a thing where you can substitute a list of symbols for a list of types.
As far as I know, when I talk to other guys from the compiler team, there is such an API, but it's internal. So their solutions for all of these problems would be something like, let's look at the class in the compiler when those things are handled and copy paste into it or macros. So that was the suggestion I got, how to solve this issue. Literally, look how we're doing it in the compiler and copy paste it. The other way is to get the quotes and manually cast it to quotes impl, and then start using private methods, and then end up with the ZO2 situation when someone changed private methods, which is, private, you shouldn't rely on it, and that broke the ZO2 with their ZO magic or whatnot, and there was a huge issue that, oh, you broke the backward compatibility. Yes, because you casted the class to its internal presentation and started using internal APIs. You shouldn't have never done it, but that's the thing that you are ending up with when you just don't have this as a part of the public API. So with Scala 2, we have quasi-codes, and they are like basically gluing strings instead of type code. But at least those strings are checked by the compiler. Like they look like a strings, but all of this Q or CQ or whatever they're triggering macros, which are or things similar to macros, which are checking that all of that makes sense. Otherwise, it won't compile. So at least we have that. Like no help from the IDE, but at least we have something checked. On Scala 3, we can glue expressions as if it was normal code, so we can have some code completion and stuff. But it only works for expression. For everything else, we are building AST manually, and it's going to be a lot of fun. So what are the issues we might have when working with APIs? So basically, if we want to provide some debug capabilities to the users, we cannot really rely on print lines. Like if we're working locally, print line might be very, very useful, but much more useful things are on Scala 2 and Scala 3, those features for reporting, because they appear in the console. They're being reported by Scala metals. If you're using IDE, they might be reported by IDEA. If you have this code in SCSI, then those little things will generate you nice inline hints, and you can just hover and see some nice information from the macro. But the problem with that is that only the first message will be printed. So if you want to use this stuff, you have to basically come up with your own writer pattern or some global string builder or whatever, so that you could throw all your logs there, and at the end of the macro, call this method exactly once if you want to log from the macro. So not really useful. Sorry, really useful, but not really convenient. Print line is really convenient because it prints, but it's only going to be printing if the compiler that you are running, it's happening in the terminal, not as a build server. If you are using any sort of build server, it's not passing you all the print line messages because there are other streams, so you have none of this information. And also, another issue is that probably some of you would like to have something like cats or Zio or whatever used in the macros, because you might want to aggregate the errors. You may want to use some of those libraries to combine the logs if you want to use these things, because doing it manually, it kind of sucks. But if we try to put all of these huge ecosystems inside our macros, then we might have some clashes with the runtime, because in the macro we have the same class path that the runtime will see. So if we put, for instance, cats and use them inside our macros, then the version that we have in cats kind of interface with the version we will see in the runtime. Like we cannot have two different versions of the library, one in macros, one in runtime. So it might be clashing. And then you can have some issues like, okay, I need to update this library in runtime, but it will break our macros, and those macros are not maintained anymore. So we cannot really do this. So it would be much better for everyone if things like cats, Zio, any other big library. So if you separated whatever you're using on the runtime and in the compile time, it's much maintainability much easier. So let us imagine a little bit a better API. So, okay, let's say we have something around macro I/O. Like we're not doing any actual I/O inside macros, but just if you are familiar with all of those monads, so let's say you can reuse your intuitions and build code this way, and use it to aggregate errors and having something like part traverse, not for parallels because it's obviously like sequential code, but to have several independent computations and then aggregate them to, for instance, aggregate the errors. So that we could have like multiple error messages and combine them into one to provide to the user single error messages, but telling him about all of the possible issues from the macro. So let's say that we can also nicely log from the macro, that we can have some structural logging, so that if we want to print from the macro, users will receive something easy to read and something easy to debug, which is also completely optional and shouldn't be taxing on the compile times if users do not use it. also assume that this is a thing, so that we can use something like a direct style, because sometimes monadic API is not going to work. Like if we wanted to create this type class, like new show, like from the cats show, we want to derive it using macros, and if we wanted to derive the body, where to the derivation function we would pass the input parameter as an expression, there is no way you can express this code using maps and flat maps. With direct style, it is possible. So if we wanted to compile it against Scala 2 and Scala 3, unfortunately we have to do some changes like passing the await explicitly, but yeah, let's imagine it is possible to use direct style if we need it for cases like this. Let us also imagine that creating this pattern matching on types, if we are working on Scala 2, on Scala 3 not so much, but on Scala 3 2, let's imagine that we can just call some utility and it would create an extractor for us, which would be extracting those values and make it useful for us with no way of making an easy mistake. Let us also imagine that if we want to work with like case classes or seal traits, we have something that has API similar to Magnolia, but for macros, so that we could easily like call a constructor, make sure that if we didn't handle anything, we would receive an ITER, so we would get some message what we messed up, so that we could handle it. So let us also imagine that if we wanted to pattern match on something like seal trait, we also have some API that, okay, let's match on this type, if it's an enum, and let's handle all of the cases, like what would we do if we match on this subtype. So this kind of API would be much, much nicer for everyone. It would simplify a lot of things if we provided these kinds of utilities for the users. It would be nice if something like that exists. And it actually does exist. I've created a Hearth, and Hearth is a proof of concept library based on my experience with Chimney Macro Commons, where I try to make as much as possible to share the code between Scala 2 and Scala 3, because with some libraries you have so much code, you don't want to maintain two code bases, which would be inevitable if you try to write separately everything for Scala 2 and for Scala 3. So we have to come up with some way to share as much code as possible, and we came up with Chimney Macro Commons, but it's like too Chimney specific to be able to reuse it in other libraries. So Hearth is my attempt to make it possible to generalize the Chimney Macro Commons approach to other use cases. And I believe it's quite a good proof of concept, even though sometimes I have to call macro within my macro, and sometimes I have to call compiler plugin to rewrite untyped trees. So, but still, it works. If anyone is interested, the demo of a Hearth, when I'm doing the derivation of a show type class, is available at Hearth's repository. Those are the classes that you would find interesting if you try to read the code, because it doesn't make sense to like show you a few hundred lines of code and on the slides. It's much easier to go through with IDE. So let's just talk about a few things that might be non-obvious, which we haven't mentioned yet. How would we kick off this cross-compilable macro? Like, let's just focus on those macros that could be cross-compilable for Scala 2 and Scala 3. It's completely optional. You don't have to do this, but if you wanted to do, how could you do this? Well, let's start with regular code. This is our show type class. It's going to be just, it's two-string on steroids. And all of our derived code done by the macro will be shoved off to some show companion compat different for Scala 2 and Scala 3. Unfortunately, some adapters are needed. And the cross-compilable part will be just a trait. As you can see, we have something like macro commons, and this macro commons as a mixin, it provides all of the API that we could use to run all of the stuff that we would like to do on both Scala 2 and Scala 3, like the cross-compilable version of types and expressions and utilities for calling the constructor, getting the methods for a type, things like that. Then we have to write some adapters when we basically mix in the trait into something that provides the implementation separately for Scala 2 and Scala 3. So basically a cake pattern, but very, very limited, so it's bearable. And if we are curious about the internals, like I'm not gonna go through all of the code. I believe it's better to look at it in the IDE, but we can just do some nice utilities like creating our own error sealed traits that we could basically have some nice finite list of possible errors to handle. We have this one single method which would generate the expression or error, and then we can say, okay, I want to generate this expression inside a name scope, so that it will be nicely indented if we wanted to print the logs. And then once I get the result in the form of MIO or of expression, I would either get the expression or I would prepare some nice pretty printed message. So because we are not handling single error but multiple, we'll have something like non-empty vector of exceptions, and we could turn this non-empty vector of exceptions in whatever way we would like into some nice string for a user. Similarly, if there are some logs matched as errors, because we can have multiple log levels, we can all combine all of that into a message for users in whatever way we like. And about this attempt, because you might be curious what it's actually doing. So basically, I learned that when you're writing a large macros, you want to decompose things, and it's usually really nice to think about, okay, let's have a set of rules which are like pattern matching. If this first case apply, let's do this. Otherwise, let's try to apply the second rule. If it's not matching, then let's try to apply the third rule. And the first rule that matches that decides if the compilation succeeded or not. But it can also like succeed or not. So we would have something like a result of option of the expression. So we can just then write all of these rules like that, define all of the bodies for all of these possible cases that we would like to handle, and then write some simple code which would be like, okay, let's try this. If it's not gonna work, then or else. This await is basically direct style which turns me of something into that something. In this case, these are options of expressions. So on the first error, we will return the error. If there are no errors, then first option that returns some will generate the result that we want to get. But I also promised you something about logging. So the approach we have in Chimney will be something like, if you want to log the stuff for the users, we don't want to have it turned on for every single case. But we might want to log if user explicitly imported some implicit into the scope. And if it is implicit in the scope, then we should like print the logs from the macro, or be able to set up some global compiler flag that would enable it for every single compilation. So let's do this. We just created some trait. Then we created an implicit for this trait. We just have to make sure that this implicit isn't always in scope, because that would be completely missing the purpose. Then we can write some really simple code. As you can see, we just taking this type of log derivation, try to summon it. If we are able to summon it, then okay, this flag is flipped. Otherwise, we can try the other stuff when we can get all of the settings from X macro settings, which is something that we are able to pass on both Scala 2 and Scala 3. And then we're doing something like parsing all of those settings into something like basically something similar to JSON, so that we wouldn't work with like raw strings, but something more useful. And then we can just look into the string. Is there some object called show, so that we could aggregate all of those our options in one place? Yes. Does it have something like log derivations? Sure. Is it a Boolean? Yes. Is it value true? If yes, then we are also flipping this flag. Otherwise, we're assuming that we shouldn't show the log. And finally, we just need to call this function when we are preparing this final expression handling. And then we can have something nice like this. We can run our code and see that, okay, in this place, we logged from the macro, and you can see we tried this, it failed, we tried this, it failed, we tried this. Oh, this succeeded, so let's try to handle all of the fields of a case class, how it went. So that should be like really, really easy to understand. Like, as long as we provide reasonable reasonable logs, just like in any other application. And this might look as something that you could do with print lines, but this, on the other hand, is not something you do with print lines. You can see that as long as I have this import, I have this blue curly line, and when I hover over it, I get the logs from the macro. And I believe this is something that should be a standard. Like, people are complaining that macros are undebuggable, impossible to debug, and with just this simple trick, you could provide this sort of utilities for all of your users so that they wouldn't have to, look into your code, what went wrong and why, etc. So for me, it's a huge gain. So the summary. So I hope that I managed to show you why good macros could be a better alternative to shapeless mirrors, but I also hope that you understand why it's so hard to have a good macros, and that it would be nice if we had some sort of utility to make it easier so that all of us could benefit from it, so that we could have macros which are performant and quick to compile and with good error messages and easy to debug. So this library is a proof of concept. My goal is not to convince anyone that this is the way, so everyone should commit to this. I just hope to inspire people to try to look for more ways to make macros more possible. If some other library comes up from it, I don't mind, as long as all of us could benefit from this mature ecosystem of libraries, which are reliable and good for the juniors, as opposed to things developed on top of shapeless or mirrors, which is really nice for prototyping, but not necessarily good for production. But I hope that I convinced you that we can improve the situation and we can do something about it. Whether we do, it's up to you. Thank you.
Hello, thank you. It was very inspiring. I want to ask one question on terminology. Why async await? Because it, to me, it looks like more like a match case or whatever. Async await.
So I call it async await because I had no better name. That's the simple way of putting it. Like, if you see what Oderski is doing with direct style, the terminology is just being like established. So yesterday I heard that he called it like prompt and effect, but those names are like, we don't have one established name for all of this stuff. Like, you have like boundary and break when we are handling returns. We have some stuff for eiders if we're using aux, but if we want to have something like a type class for handling things like that, I haven't seen any established one single terminology. Like, some similar cases are when I'm seeing async and await, or when I see boundary break, or prompt and effect, or something if you're using algebraic effects with all of those suspend and resume. So there's a lot of names, but none of them is really good if you want to have a generic type class, if you ask me. So I have to pick up something.
Seeing async strongly implies some background execution or concurrency. So that,
yeah.
And one more. When I would be using this, can it cooperate with Scala 3 macros when I am not interested in Scala 2? Could I mix it with?
Yes. So while I'm defining all of those features in standard rate, and you have to mix it in if you are cross-compiling, I also want to provide like a class which only takes quotes as an implicit parameter that you could instantiate and import all of its utilities. That would work only for Scala 3, but then you wouldn't have all of the burden for using utilities for Scala 2 if you don't need it. So quite a lot of this stuff, in my opinion, could be like, opt-in. If you want to use it, you use it. If you don't want to, you don't, and you don't have the overhead.
Yeah. So you think it could be when I want features which are not provided by the library and I want to implement them on my own with Scala 3 macros, I can mix it.
Yes, that is the goal. Like, I want to develop this library in such a way that all of that is opt-in. You can use Mio, but you don't have to. You can use some FP stuff, but you don't have to. You can use cross-compilation, but you don't have to. Everything should be opt-in so that it helps you, but don't get in your way.
Yeah, thank you. And I will pass the mic away, but before I do, I would like to get some impression. How much of you folks are still interested about Scala 2 macros?
Thanks, Mateusz. It was a great talk, and the library looks really promising. So this is like a follow-up to the previous question. I have some existing Scala 3 macros, and like I like the way the logging works, especially the fact that it is scoped and you can provide a lot of like debugging information. Do you feel that like this is a good first step to use the library only for logging for the existing macros to improve the DX, or is it like, you know, all in?
So the logging macros are in a separate module that the main library depends on. So if you want to, you can only just import like Hearth FP, which contains Mio and a very, very few type classes. Like I only were interested in stuff like applicative and traverse basically, and parallel in the CATS meaning, not in the CS meaning, when you're just on independent computations, but not necessarily running on different threads. So it's a very, very lean micro FP library, and if you're only interested in Mio, then yes, you can just use Mio and nothing else.
Cool, thank you.
Thank you for the presentation. I have nearly zero experience with micro, and I used to, I tried it, but I found it very, very hard. One of the reasons is I couldn't find any documentation, very detailed documentation about that. So where can I find them?
So to be honest, I believe there isn't much documentations yet. When I was learning macros, like 90% of the time it was either trial and error, like print the expression and try to reproduce it, and then learn that for reasons whatever you cannot do this because there's some APIs are private. Or option B, look at other existing macro libraries when someone already solved this issue, and probably they solved this issue because they were nagging the compiler developers to give them the answer in some of the tickets on Scala 2. So unfortunately, it's not very user-friendly, and that's also part of why I wanted to have something like a standard library, because quite a lot of these issues, like, you can solve it. Sometimes solution takes like 50 lines of code that you could copy-paste, but if someone found an issue there and someone fixed it, then no way that everyone is copy-pasting this fixed version again. So if we had just a single place when everyone can contribute with those utilities so that everyone can benefit if it's the bug spot and we fix it, that would be great. So that we wouldn't have to go to this AST stuff and avoid it as much as possible. And I don't want to like aim for 100% feature parity with AST. It doesn't make sense in my opinion. For my opinion, the best approach would be something like Pareto principle. Let's design API with the 20% of the effort that is covering 80% of the most common cases. Like if you have some messed up higher candidate types working on dependent types and things like that, okay, I'm not gonna handling, sorry. But for these cases like simple case classes, for starters, and sealed traits, and just applying tags, things like that, very, very simple things that it's very, very easy to get wrong. We can start with that and then build on top of it and expand, handle cases, while never promising to cover everything because it's impossible and I don't see the point.
I have a question about expert.quote. So I suppose it's a macro itself. Anyway, so the AST that it receives, does it need to understand it all or a subset of Scala, or does it somehow transparently flow through Hearth all the way to the generated code? Or another way to phrase that, like, is all of Scala supported in that, or just some subset that, that the expert quote understands?
So I'm going to be open with you. This is a proof of concept, so I try to handle enough cases to make my demo work, and I'm fairly certain that if you start doing more stuff inside, then you're going to get more and more corner cases. Like, the way I was able to create cross quotes inside Scala 2, like Scala 2 have no things like, okay, if there is some implicit of your type, we're gonna automatically pull it and use it. Scala 3 does it, Scala 2 don't. In Scala 2 you would have to use string interpolation to manually inject the type. So for handling all of this kind of stuff, well, I had to do some dirty things like looking around the scope, see if there are some implicits, trying to apply them or not, and try to print the tree of the expression I received, and then copy-paste it inside to generate the expression with a quasi-quote which will be expanded by the macro. So we have macros inside the macros, and inside this macro I am basically writing macro to expand. So this is next level insane.
I guess all the more support to drop, all the more reason to drop Scala to macros.
Yes. On Scala 3 I also had to do a little bit more tricks in a different way, but still. Like on Scala 3, on the other hand, you have this issue that we have nested quotes and expressions. Then each nested quote would be using different quotes. So implicitly, there's new nested quote generator that will be used inside. So if you would like to nicely have a quote inside of it, a quote inside of it, a quote, then you should be, by principle, passing around those implicit quotes always, because the quotes will change inside those nested quotes and splicing. And it is inconvenient, so I solved that, and it involves having some global var, which is setting and unsetting these quotes, and this way I can work around it. It's very, very ugly, but it works, at least for some cases. So yes.
Thank you.
Thank you.